What if gravity works perfectly everywhere you look, except where it matters most? You can drop a glass, watch it shatter on the floor, and feel confident that gravity behaved exactly as expected. You can track planets, predict eclipses, and send spacecraft across billions of kilometers using its equations. And yet, when physicists push those same equations to their deepest limits, inside black holes, at the birth of the universe, or at the smallest scales of reality, gravity quietly stops making sense. Tonight's question isn't whether gravity works. It's why the force we trust the most becomes the one that breaks our physics when we ask it the hardest questions. Welcome back, traveler. Tonight, we drift through science. You're lying somewhere familiar, maybe stretched out in bed with the lights already off, maybe on a couch with headphones resting gently against your ears, or maybe awake later than you planned, listening while the rest of the world slows down. Outside your room, gravity is holding cities together, pressing oceans into their basins, anchoring the moon in its endless orbit. If this kind of calm, thoughtful science feels like a good place to be at this hour, you can like the video, subscribe, or leave a comment saying where you're listening from and what time it is. Small signals, shared quietly across the night. If your mind feels busy, restless, or weighed down by thoughts that won't settle, you're not doing anything wrong. It's okay to be awake right now. It's okay to be tired, to be searching for something gentle to hold your attention, while everything else loosens its grip. You don't need to understand every concept we touch tonight, and you don't need to remember names, equations, or details. If your thoughts drift, that's fine. If you fall asleep halfway through a sentence, that's even better. This isn't a test. It's a place to rest while curiosity hums softly in the background. Tonight, we'll move slowly through gravity from several angles at once. We'll look outward to galaxies bending light and black holes stretching time, and inward to laboratories, observatories, and human hands trying to measure something that resists being pinned down. We'll pass through ideas that work beautifully and others that stubbornly refuse to fit together. This channel is for people who love big questions but need a calm place to explore them at night. And here on Orbis Sleep, we like to show not just the universe itself, but the people, instruments, mistakes, and quiet breakthroughs that shape how we try to understand it. So tonight, let's take this one force seriously, not as a solved problem, but as an open invitation. We'll walk slowly through gravity as it curves space, stretches time, and slips through the cracks between our greatest theories. You don't have to follow every step. You can simply listen, letting images form and fade at their own pace. If it feels right, dim the screen, adjust your pillow, and let your body settle. Nothing here needs fixing. The journey is gentle, and it's just beginning. You're still lying there, exactly where you were a moment ago, feeling the quiet weight of your body pressing gently into the bed. Gravity is doing its most familiar work right now, holding you in place without effort or announcement. You don't feel it the way you feel wind or heat. You feel it as steadiness, as the simple fact that things stay where they are unless disturbed. This quiet presence is part of why gravity feels so trustworthy. It never asks for attention. It just holds, night after night, while everything else changes around you. For most of human history, gravity didn't feel mysterious at all. It felt obvious. Objects fall, stones drop, rain comes down instead of drifting sideways into the sky. Even animals seem to understand it instinctively, adjusting their movements without thinking. Long before equations or telescopes, gravity was woven into daily survival. It shaped how shelters were built, how tools were used, how bodies learned balance. There was no need to question it deeply because it behaved the same way every time. Reliability has a way of hiding its own strangeness. When early thinkers did begin to wonder about gravity, they imagined it as something pulling downward toward the center of the Earth. It made intuitive sense. Down was where things wanted to go, Up was where effort was required. For centuries, this simple picture was enough. Gravity was treated as a tendency, not a force that needed explanation. It was part of the background, like darkness at night or silence between sounds. The universe, in this view, didn't need gravity explained. It just needed it acknowledged. Everything changed when humans started looking up instead of down. When the same force that pulls an apple toward the ground was noticed holding the moon in its path, the story quietly deepened. Suddenly, gravity wasn't just local, it reached across space. It linked the fall of a stone to the motion of planets. Isaac Newton put this connection into mathematics, showing that the same rule applied everywhere. With a single equation, gravity became universal. It could predict orbits, tides, and the slow dance of celestial bodies with remarkable accuracy. Newton's gravity worked so well that it felt final. For more than 200 years, it explained nearly everything anyone could observe. Engineers trusted it to build bridges. Astronomers trusted it to chart the heavens. The equation was simple, elegant, and powerful. Two masses attract each other, stronger when closer, weaker when farther apart. No drama, no mystery. Gravity became the most dependable tool in physics, the one you reached for when everything else felt uncertain. It earned a reputation as the sensible force. As you lie here listening, it's worth noticing how much of your world still runs on that same idea. Satellites orbit Earth, using equations rooted in Newton's work. Space agencies calculate trajectories with it every day. Even now, spacecraft billions of kilometers away respond exactly as predicted. In practical terms, gravity seems solved. It behaves, it obeys, it delivers results. This is what makes the next part of the story so strange, because despite all that success, something fundamental is missing. Newton could describe how gravity works, but not what it is. His equation tells masses how to move, but it never explains why they attract each other in the first place. Newton himself was uncomfortable with this gap. He avoided speculating too deeply, aware that the mechanism behind gravity remained invisible. It was as if the universe followed the rules perfectly, but refused to reveal the reason for those rules. The math worked, but the understanding stayed incomplete. For a long time, that incompleteness didn't seem urgent. As long as predictions matched reality, the missing explanation felt like a philosophical footnote. But as measurements became more precise, tiny cracks began to appear. Orbits shifted in subtle ways. Mercury, in particular, refused to move exactly as Newton's gravity predicted. The difference was small, barely noticeable, but persistent. Something was off. Gravity still worked, but not perfectly. The universe was whispering that the story wasn't finished yet. Enter Albert Einstein, who approached gravity from an entirely different angle. Instead of treating it as a force pulling objects together, he imagined gravity as a bending of space and time themselves. Mass didn't tug at other mass. It reshaped the stage on which everything moved. Planets followed curved paths because space around them was curved. Time slowed near heavy objects because time itself was stretched. Gravity stopped being a pull and became a geometry. This idea was strange, beautiful, and unsettling all at once. Einstein's theory of general relativity fixed Mercury's orbit instantly. It predicted new phenomena no one had seen before, like light bending around stars. When astronomers finally observed that bending during a solar eclipse in 1919, gravity revealed a deeper layer. Space and time were not rigid backgrounds. They were flexible, responsive, alive. Gravity was no longer just something things did. It was something reality became in the presence of mass and energy. You might imagine this discovery happening in quiet rooms filled with chalk dust and long equations stretching across blackboards. Scientists argued, recalculated, doubted themselves, and checked the sky again and again. Observatories refined their instruments. Data was corrected, recalibrated, and sometimes thrown out entirely. Gravity wasn't announcing its secrets clearly. Humans had to coax them out carefully, patiently, often making mistakes along the way. The universe didn't make it easy, but it did reward persistence. For a while, it felt like gravity had finally been understood. General relativity worked where Newton failed. It explained black holes, gravitational waves, and the expansion of the universe. It passed every test thrown at it. But as comforting as that success was, it carried an uncomfortable truth. This new picture of gravity didn't play well with another wildly successful theory, quantum mechanics. The rules governing the very small refused to align with the rules governing gravity. Quantum mechanics describes particles as probabilities, fluctuations, and uncertainties. It thrives on randomness. Gravity, in Einstein's view, is smooth, continuous, and geometric. When physicists tried to combine them, the equations collapsed into infinities. The math exploded. Predictions lost meaning. It was as if gravity simply refused to enter the quantum world politely. It worked beautifully on large scales and completely broke down on small ones. The most reliable force became the most uncooperative. So here we are, lying comfortably under the influence of a force that shapes galaxies, holds stars together, and yet refuses to fit into our deepest theories. Gravity behaves everywhere you look until you ask it to explain itself fully. And if you're somehow still awake at this point, quietly following along with a force that everyone thinks they understand, but no one truly does, you're exactly the kind of nighttime explorer this channel exists for. You can subscribe if you'd like more calm science stories waiting for you whenever sleep feels a little far away. Somewhere far above the roof over your head, gravity is quietly shaping paths you'll never see directly, not as a pull you can point to, but as a gentle guidance system woven into the structure of space itself. Even while you remain still, planets are gliding along invisible curves, stars are orbiting dense centers, and entire galaxies are tracing slow arcs through darkness. Gravity doesn't rush them, it gives them time. It prefers patience over force, slow inevitability over sudden motion. When Einstein reimagined gravity as curved space and time, he removed the idea of a mysterious pulling force altogether. Instead, mass tells space how to bend, and space tells matter how to move. Picture a stretched fabric, smooth and quiet, with a heavy object resting at its center. Anything nearby rolls inward, not because it's pulled, but because the surface itself is sloped. This metaphor isn't perfect, but it hints at something radical. Gravity is geometry behaving seriously. What makes this idea so unsettling is that space and time were once thought of as rigid containers, empty stages where events happened. Einstein turned them into participants. Space could stretch, compress, ripple, and warp. Time could slow down, speed up, and fall out of sync. Gravity wasn't added on top of reality. It was revealed as part of its skeleton. The universe wasn't a machine obeying gravity. It was gravity expressing itself as structure. You don't need a telescope to feel this shift in perspective. It's enough to notice how still everything feels right now. Gravity isn't yanking you downward. It's defining what down even means. The direction your body recognizes as rest is set by curved space-time around Earth. Without gravity shaping that geometry, up and down would lose their meaning entirely. Orientation itself is a gift gravity quietly provides. One of the most striking predictions of this new view was that light would bend, not slow down because it got tired, not curve because it had weight, but because space itself was curved near massive objects. In 1919, during a total solar eclipse, astronomers measured starlight passing near the sun and found it bent exactly as Einstein predicted. The stars appeared slightly out of place, nudged by gravity's influence on space. The universe had just nodded in agreement. That measurement wasn't easy. Scientists traveled across oceans with delicate instruments, hoping clouds wouldn't ruin everything. They argued over blurry photographic plates and faint smudges of light. Some doubted the results, others recalculated endlessly. But when the numbers settled, gravity revealed itself as something deeper than anyone had imagined. Space wasn't empty. It was active, responsive, quietly expressive. From that moment on, gravity became less about falling and more about flowing. Objects followed the straightest possible paths in curved space, called geodesics. They weren't being dragged around. They were simply obeying the shape of reality beneath them. Planets weren't struggling to stay in orbit. They were resting in motion, moving naturally through a bent cosmic landscape. Even now, satellites orbit Earth by following these curved paths. Engineers correct for relativistic effects, so GPS signals stay accurate. Time itself runs slightly slower closer to Earth than it does farther away. Your phone adjusts for this automatically, compensating for gravity's influence on time without ever telling you. Gravity is woven so deeply into your life that it corrects your sense of location while remaining completely unnoticed. But elegance has its limits. The smooth curves of space-time work beautifully on large scales: planets, stars, galaxies. Trouble begins when we look too closely. When distances shrink and energies rise, the smooth picture starts to crack. At very small scales, reality becomes grainy, uncertain, restless. Quantum mechanics takes over, insisting that nothing is truly smooth, not even space itself. Here, gravity seems uncomfortable. Its equations assume continuity, but the quantum world insists on discreteness. When physicists try to apply Einstein's gravity to particles, the math spirals into infinities that refuse to cancel out. Predictions lose meaning. The geometry collapses under its own assumptions. It's as if gravity was never meant to be examined under a microscope. This tension isn't philosophical, it's practical. Inside black holes, gravity becomes extreme and quantum effects should matter. At the very beginning of the universe, when everything was unimaginably dense, both gravity and quantum mechanics were essential, and yet our equations fail precisely where reality demands the most clarity. Gravity doesn't misbehave gently, it breaks completely. Researchers have tried many paths forward. Some imagine gravity as emerging from deeper quantum processes, like temperature emerging from motion. Others propose tiny vibrating strings, extra dimensions curled up beyond perception, or networks of discrete space-time points. Laboratories search for quantum hints of gravity. Observatories listen for ripples in space-time from distant collisions. Progress comes slowly, often through dead ends. You can imagine scientists late at night, staring at equations that almost work, sensing that gravity is hiding something simple behind layers of complexity. They adjust models, rewrite assumptions, and test new ideas, knowing that most will fail. Gravity doesn't offer shortcuts. It rewards patience and humility, and it punishes certainty. As you listen, you're still safely held by the same force that's causing all this trouble. Gravity hasn't changed its behavior just because we don't understand it fully. It continues shaping stars and resting your body exactly where it needs to be. The mystery isn't in what gravity does. The mystery is in why it does it so reliably, yet refuses to tell us how at the deepest level. And while these questions unfold far beyond your room, nothing here requires effort from you. You don't have to solve gravity tonight. You're only tracing its outline, letting its strangeness pass gently through your thoughts. The universe can remain unresolved for now. Gravity will keep holding everything together while you simply listen. At the edges of what gravity can do, the universe stops behaving politely. Far from the calm pull that keeps you resting comfortably, gravity becomes intense, concentrated, almost overwhelming. In these regions, space tightens, time slows, and familiar intuitions dissolve. You don't notice this where you are, but somewhere beyond your ceiling, gravity is stretching itself to its limits, quietly revealing that its gentle reputation is only part of the story. Black holes are where this tension becomes impossible to ignore. They are not objects in the usual sense, but regions where gravity has curved space so severely that nothing escapes. Not light, not time, not information, at least as far as our equations can tell. The math insists that at the center of a black hole lies a singularity, a point of infinite density where space and time break down completely. Physics doesn't just struggle there, it gives up. What's unsettling is how confidently gravity leads us to this cliff. General relativity predicts black holes with remarkable precision, their masses, their horizons, even the way they merge and send ripples across space-time. And yet, at the very heart of these predictions sits an impossibility: infinity. In physics, infinity is a warning sign. It's nature telling us that our description has gone too far without enough understanding. You might imagine falling toward one of these cosmic abysses, not dramatically but quietly. From far away, nothing seems strange. Stars orbit as expected. Space feels normal. Only as you approach does gravity tighten its grip. Time for you slows compared to the outside universe. Paths that once felt straight begin to curve inward. Reality narrows gently but relentlessly, guiding everything toward a place our theories cannot describe. Scientists didn't find black holes by accident. They followed gravity's equations to their logical conclusion, even when the results felt absurd. At first, many hoped singularities were mathematical mistakes. Perhaps symmetry would break them apart. Perhaps nature would avoid infinities somehow. But observation after observation closed those escape routes. Black holes were not just possible, they were everywhere. Telescopes began to detect stars orbiting invisible centers. Gas spiraled into darkness, heating up and glowing before vanishing. In 2015, detectors on Earth felt space-time itself ripple as two black holes collided over 1 billion light-years away. The signal matched Einstein's equations perfectly. Gravity was right again, right up until the moment where understanding stops. The same breakdown appears when we rewind the universe itself. Tracing cosmic expansion backward leads to the Big Bang, a moment when everything was compressed into an unimaginably small volume. Density skyrockets, temperature explodes, space and time themselves emerge from something undefined. Once again, gravity predicts its own failure. The equations point directly toward a singular beginning they cannot explain. Here, gravity clashes with quantum mechanics in the most dramatic way. Quantum theory says the universe should be jittery, uncertain, fluctuating at tiny scales. Gravity insists on smoothness. When forced together, their languages collide. Space cannot be both continuous and grainy. Time cannot be both flowing smoothly and breaking into probabilistic jumps. Something fundamental is missing. Physicists have tried to soften this collision by quantizing gravity, chopping it into discrete pieces like everything else in the quantum world. Others suggest gravity isn't fundamental at all, but emerges from deeper processes, the way pressure emerges from moving molecules. In these ideas, space-time itself is secondary, a macroscopic illusion arising from microscopic rules we barely glimpse. Laboratories attempt to probe gravity's quantum side with extreme precision. Tiny mirrors are cooled near absolute zero. Lasers measure minuscule vibrations. Researchers look for hints that gravity behaves differently at short distances. So far, gravity remains stubbornly classical, refusing to reveal its quantum nature directly. It hides its secrets behind scales too small and energies too high. Meanwhile, astronomers search the sky for indirect clues. The early universe acts like a natural laboratory, compressing energies beyond anything we can create on Earth. Patterns in the cosmic microwave background carry whispers of gravity's behavior at the dawn of time. These signals are faint, buried under noise, requiring years of analysis and constant recalibration. It's strangely fitting that gravity, the force that structures everything large, resists explanation at the smallest level. It connects stars and galaxies, yet slips through our fingers when we try to grasp it mathematically. Gravity seems comfortable being experienced, not understood, reliable in practice, elusive in theory. As you listen, you're suspended in this contradiction. Held securely by a force that keeps failing our deepest questions. Gravity doesn't mind the inconsistency. It doesn't slow down or hesitate. It continues shaping the universe while we argue about what it truly is. There's something humbling in that quiet indifference, and maybe that's part of the lesson unfolding tonight. Gravity doesn't promise comprehension, it offers stability instead. While scientists wrestle with infinities and broken equations, you remain supported, breathing, resting, wrapped in a mystery that doesn't demand answers before it does its work. There's a quiet boundary in science that gravity forces us to confront again and again. It's not a wall you can see or touch, but a limit on what observation itself can reach. No matter how carefully instruments are built or how long data is collected, gravity creates regions that refuse to send clear messages back. Information bends, stretches, and sometimes disappears entirely. Understanding doesn't fail loudly here. It fades gently into uncertainty. One of the strangest features gravity introduces is the event horizon of a black hole. From the outside, it looks calm and ordinary, like an invisible surface drawn in space. Cross it, and the universe effectively stops talking to you. Signals can no longer escape. Time and space trade roles, cause and effect blur. This boundary isn't just physical, it's epistemological. It marks the edge of what can be known from afar. Imagine watching an object fall toward this horizon. From your distant perspective, it never quite crosses. It slows, dims, stretches, and fades. Time appears to freeze. Gravity doesn't just trap matter here, it traps information. The universe becomes selective about what it allows observers to learn. Reality continues, but your access to it quietly shuts down. Physicists noticed something unsettling when they studied this boundary closely. If information truly disappears inside a black hole, then fundamental rules of physics are violated. Quantum mechanics insists that information is never destroyed. Gravity seems perfectly willing to erase it. This contradiction became known as the black hole information paradox, and it sits at the heart of modern theoretical physics like an unresolved whisper. Attempts to resolve this paradox led to ideas that sound almost philosophical. Some suggest information is encoded on the horizon itself, smeared across its surface like a cosmic memory. Others propose that what falls in is somehow reflected back in subtle correlations. These aren't abstract musings. They are mathematical necessities forced upon us by gravity's behavior at extremes. The human side of this struggle plays out in quiet offices and crowded conferences. Researchers argue late into the night, rewriting equations, chasing consistency. Papers are published, challenged, refined, and sometimes abandoned. Gravity doesn't reveal which path is correct. It simply continues doing what it does, indifferent to our discomfort with paradox. Observation pushes back in subtler ways too. Gravity distorts light through gravitational lensing, bending distant galaxies into arcs and rings. Astronomers must untangle these distortions to see what lies behind them. Every image becomes a puzzle. What is real shape, and what is gravity's illusion? Even looking outward, gravity insists on filtering the view. The instruments themselves feel gravity's influence. Telescopes must account for tiny shifts caused by Earth's mass. Clocks aboard satellites tick at different rates depending on altitude. Engineers quietly correct for relativistic effects, often without ceremony. Gravity is always part of the measurement, never fully removable, always shaping what data means. This creates a subtle irony. The more precisely we try to measure the universe, the more gravity inserts itself into the process. It's not just the subject of study, it's an active participant. Unlike other forces, gravity cannot be screened or turned off. It cannot be isolated in a laboratory corner. It surrounds every experiment, quietly asserting itself. Some theories suggest this isn't a flaw but a clue. Perhaps gravity isn't something that lives inside space-time, but something that defines space-time itself. If so, expecting to observe it the way we observe particles may be the wrong approach entirely. Gravity may be closer to the rules of the game than to the pieces on the board. This perspective reframes the frustration scientists feel. The difficulty isn't that gravity is hiding, it's that we're asking it the wrong questions, using tools built for a different kind of reality. Gravity may not be something to detect directly, but something to infer indirectly, through patterns, constraints, and consistency. As these ideas circulate, none offer easy closure. They shift the mystery without dissolving it. Gravity remains both deeply familiar and profoundly inaccessible. It structures everything we see, yet guards its own nature carefully. The universe, it seems, is under no obligation to be fully transparent. While all this unfolds, you remain comfortably within gravity's embrace. The paradoxes don't ripple into your room. The limits of knowledge don't disturb your rest. Gravity performs its most basic service flawlessly, even as it confounds our deepest theories. Perhaps that's the quiet balance gravity strikes. It allows us enough understanding to navigate the world, but withholds enough to keep humility alive. You don't need to resolve these boundaries tonight. You can simply notice that mystery and stability coexist, and that for now, stability is doing exactly what it's meant to do. At some point, gravity stops feeling like a thing and starts feeling like a question, not a loud one, but a persistent presence that refuses to be pinned down. After decades of trying to quantize it directly, some physicists began asking a different kind of question altogether. What if gravity isn't a fundamental force in the same way the others are? What if it's something that emerges quietly from deeper rules we haven't yet learned how to see? This shift in thinking didn't come from optimism, but from frustration. Every attempt to force gravity into the quantum framework produced infinities and contradictions. The math resisted. The theories collapsed under their own weight. Instead of pushing harder, some researchers stepped back and noticed something odd. Gravity behaves differently from every other force. It can't be shielded. It doesn't have a known particle. It doesn't weaken or strengthen the same way at small scales. Emergent gravity suggests that what we experience as gravitational attraction might arise from collective behavior. The way temperature emerges from moving atoms or pressure arises from countless collisions. No single molecule has a temperature. No single particle carries pressure. These are macroscopic effects, meaningful only when many components act together. Gravity, in this view, could be the same, a large-scale expression of microscopic information processing. This idea becomes especially compelling when you consider black holes again. Their entropy, a measure of hidden information, scales with surface area, not volume. That's deeply strange. It hints that the universe may store information on boundaries rather than interiors. If space-time itself encodes information this way, gravity could be a byproduct of how information is arranged, not a force acting independently. In laboratories and theoretical models, physicists explore this possibility using tools borrowed from thermodynamics and quantum information theory. Equations once used to describe heat now describe space-time. Concepts like entropy, entanglement, and information flow begin to replace mass and force as the primary characters. Gravity starts to look less like a push and more like a bookkeeping rule for information. These ideas are tested not with hammers or particle beams, but with thought experiments and consistency checks. Does the math preserve known laws? Does it recover Einstein's equations at large scales? Does it avoid infinities at small ones? Many proposals fail quietly. A few survive long enough to be debated. None have fully replaced the old picture, but they have changed the questions being asked. It's easy to imagine scientists late at night, staring at diagrams of space-time that resemble networks more than smooth surfaces. Lines represent relationships, not distances. Geometry becomes secondary. What matters is how pieces connect, how information flows, how correlations propagate. Gravity, in these models, isn't pulling anything. It's organizing. From this perspective, falling isn't caused by attraction. It's a tendency toward states that maximize information balance. Objects move the way they do because that's the most statistically natural configuration available. The universe, rather than being governed by force, may be guided by preference, quiet, mathematical preferences that shape everything from galaxies to your own resting body. You don't need to accept this idea for it to be calming. Whether gravity is fundamental or emergent, it still performs its role with absolute reliability. The bed beneath you doesn't care about theoretical debates. It rests where space-time allows it to rest. Your body settles into the geometry provided, regardless of how that geometry came to be. Observationally, testing emergent gravity is difficult. Predictions often differ only slightly from standard models. Astronomers search for subtle deviations in galaxy rotation, gravitational lensing, and cosmic expansion. So far, gravity behaves stubbornly as expected. But even this resistance teaches something important. Whatever gravity is, it is deeply consistent. There's a quiet reverence in admitting we may be mistaking description for cause. Perhaps our equations describe patterns without revealing origins. Perhaps gravity is a language the universe uses, not the underlying grammar itself. If so, understanding gravity fully may require learning a new way of thinking rather than refining old tools. This uncertainty doesn't weaken science. It strengthens it. It keeps curiosity alive and arrogance in check. Gravity's refusal to fit neatly into our frameworks reminds us that the universe is under no obligation to be simple, only coherent, and coherence can exist without complete explanation. As you continue listening, the idea that gravity might be emergent doesn't need to feel destabilizing. It can feel like standing near a deep ocean at night, aware of vast structures beneath the surface without needing to see them. The water holds you either way. Tonight, gravity remains faithful to its task. It supports you, steadies your breathing, and shapes your sense of stillness. Whatever its true nature, it continues doing its quiet work while our understanding catches up at its own unhurried pace. Time feels steady where you are. It moves forward at a familiar pace, marked by breath, by the quiet passing of minutes, by the soft awareness of being awake or drifting closer to sleep. Gravity, however, does not agree that time should behave the same everywhere. It reshapes time as confidently as it reshapes space, stretching it, slowing it, and sometimes pulling it so thin that it nearly stops altogether. This connection between gravity and time wasn't obvious at first. For centuries, time was assumed to flow uniformly, ticking away in the same rhythm for everyone, everywhere. Einstein changed that assumption gently but permanently. In his picture, time responds to mass. The stronger the gravitational field, the slower time passes. Clocks don't merely measure time, they experience it differently depending on where they are. Near Earth, this effect is subtle but real. Clocks on satellites tick slightly faster than clocks on the ground because they feel less gravity. Engineers correct for this difference constantly. Without those adjustments, GPS systems would drift by kilometers each day. Gravity quietly edits time, and modern technology works only because we listen carefully to those edits. Farther out, gravity's influence on time becomes dramatic. Near a black hole, time stretches almost to a standstill. From the outside, objects falling inward appear to freeze, their clocks slowing endlessly. For them, time continues normally, but the universe beyond races ahead. Gravity doesn't just bend paths here, it separates experiences of time itself. This creates a strange layering of reality. Different regions of the universe carry their own tempos, set by gravity's strength. There is no single cosmic clock ticking in the background. Time fractures into local rhythms, each shaped by mass and motion. The universe is less like a synchronized machine and more like a vast composition played at different speeds. Physicists discovered this not through poetry, but through stubborn equations and careful measurement. They checked predictions against pulsars, atomic clocks, and spacecraft signals. Again and again, gravity insisted that time was flexible. Each confirmation felt less like a surprise and more like a quiet affirmation that reality was stranger than comfort allowed. Yet when gravity and time intertwine at the smallest scales, familiar logic dissolves. Quantum mechanics treats time as a fixed parameter, a clean axis along which change occurs. Gravity refuses this simplicity. If time itself can stretch and slow, how can it remain fixed in quantum equations? The two frameworks talk past each other, describing incompatible worlds. This mismatch becomes critical in extreme conditions. At the beginning of the universe, time as we know it may not have existed at all. The equations suggest a boundary where time emerges from something undefined. Gravity leads us there confidently, then leaves us without language. The concept of before loses meaning, and causality itself becomes uncertain. Researchers attempt to navigate this by reimagining time not as a fundamental ingredient, but as an emergent one. In some models, time arises from change, from relationships, from information flow. Gravity, in turn, governs how those relationships unfold. Time becomes less like a river and more like a pattern traced by interactions. These ideas are explored through abstract mathematics and careful analogy. Scientists debate whether time is fundamental or derived, whether it flows or simply appears to flow. Experiments search for tiny violations, small hints that time behaves differently under extreme gravity. So far, gravity remains consistent, but silent about its deeper intentions. There's something quietly unsettling in this silence. Time defines memory, aging, anticipation. Gravity's influence on it suggests that even these deeply personal experiences are tied to cosmic structure. Your sense of now is shaped, in part, by the mass of Earth beneath you and the geometry of space-time around it. And yet, this connection can feel grounding rather than alarming. Gravity doesn't rush time where you are. It allows moments to stretch gently, to soften. The same force that warps time near black holes grants you a steady rhythm tonight, one breath following another without effort. You're participating in this cosmic relationship without needing to think about it. Time flows calmly for you because gravity here is calm. The universe has chosen this balance for this place, There's no urgency in that choice, only quiet stability. As theories struggle to unify gravity and time at the deepest level, your experience remains intact. The mystery doesn't interfere with rest. You don't need to solve the nature of time to feel it passing gently. Gravity keeps the tempo slow and familiar, exactly as it should be. For now, it's enough to notice that the force reshaping galaxies also shapes the pace of your night. Gravity holds time open here, giving you space to listen, to wander in thought, or to drift peacefully towards sleep. There is a quiet discomfort in astronomy that gravity exposes without explanation. When scientists measure how fast galaxies rotate, the numbers don't add up. Stars at the edges move far too quickly, as if held by something unseen. According to the gravity we understand, these galaxies should tear themselves apart. And yet, they remain whole, spinning calmly in the dark. This mismatch wasn't discovered through speculation, but through careful observation. In the 1970s, astronomers charted rotation curves with increasing precision. Instead of slowing with distance, stars maintained nearly constant speeds. Gravity, applied honestly, demanded more mass than could be seen. Something invisible was helping hold galaxies together. The simplest explanation was unsettling. There had to be more matter than what telescopes could detect. Not gas, not dust, not stars. Something dark, transparent, and abundant. Gravity was revealing its presence indirectly, through motion alone. Light told one story, gravity told another. You can imagine researchers late at night, recalculating data, checking instruments, hoping for error. But the signal persisted across galaxies, clusters and scales. Gravitational lensing confirmed it. Light bent more than visible matter allowed. Gravity kept pointing towards something missing. This unseen mass became known as dark matter, not because it is sinister, but because it doesn't interact with light. It neither emits nor absorbs radiation. It announces itself only through gravity's quiet accounting. Galaxies move as if embedded in vast, invisible halos, extending far beyond what we can see. From your perspective, lying still, this absence feels abstract. But dark matter outweighs ordinary matter by a factor of about 5 to 1. Most of the universe's mass is invisible to eyes and instruments designed to detect light. Gravity feels this mass intimately. It responds faithfully, even when everything else remains blind. Physicists have tried to identify dark matter directly. Underground detectors listen for faint collisions. Space telescopes scan for decay signals. Particle accelerators attempt to create it artificially. So far, dark matter remains elusive. Gravity seems to know it well but refuses to translate. Some have proposed an alternative. Perhaps gravity itself behaves differently at large scales. Maybe the equations change subtly when accelerations are tiny. Modified gravity theories attempt to explain galactic motion without dark matter. They work in some cases, fail in others. Gravity remains non-committal. What's striking is how calm the universe appears despite this missing understanding. Galaxies don't wobble anxiously. Clusters don't unravel. The cosmos behaves as if the rules are settled, even while our descriptions lag behind. Gravity continues enforcing consistency, whether or not we've named all the ingredients. This creates a strange reversal. Instead of light revealing matter, gravity reveals absence. Instead of seeing and then explaining motion, we see motion and infer unseen structure. The universe invites us to trust gravity's testimony, even when our senses disagree. In human terms, this is deeply humbling. We like to believe that observation equals understanding. Gravity reminds us that some truths are felt rather than seen. The most influential components of reality may leave no visual trace at all. You don't experience this absence as loss. Gravity here is complete enough to hold you comfortably. It doesn't feel lacking or uncertain. The same force that demands invisible mass on cosmic scales provides reliable stability on human ones. Perhaps this is why gravity unsettles us. It keeps working even when our explanations fail. It asks us to accept that reality can be structured by things we cannot directly observe, and that this doesn't make it any less real. As you rest, it's okay to let this idea soften rather than sharpen. The universe can remain partially unseen without becoming hostile. Gravity will keep shaping it faithfully, holding together what we know and what we've yet to discover, while you simply listen. At a certain point in the night, gravity starts to feel less like a mystery to solve and more like a presence to sit with. Not dramatic, not demanding, just quietly there. It's the force that never leaves, the one that accompanies everything from the first moment of structure to the last slow fading of motion. In that sense, gravity is patient. It doesn't rush beginnings, and it doesn't hurry endings either. Every star you've ever heard of is living on borrowed balance. Gravity pulls inward, pressure pushes outward, and for millions or billions of years, the two negotiate a fragile truce. Eventually, fuel runs out, pressure weakens, gravity wins, not violently but inevitably. Stars swell, shed layers, collapse, or cool into quiet remnants. Gravity doesn't destroy them out of cruelty. It simply finishes the conversation they started. You can imagine this playing out far away, where time stretches long enough to feel almost unreal. White dwarfs slowly dim over trillions of years. Neutron stars spin, radiating energy away like tired lighthouses. Black holes linger long after everything else has gone dark, holding onto mass and memory in silence. Gravity outlasts light, heat, and motion. It is what remains when excitement fades. This endurance gives gravity a melancholic tone. It's not sad in a human sense, but it carries the weight of inevitability. Everything that forms under gravity eventually changes because of it. Mountains erode, orbits shift, even galaxies drift apart as cosmic expansion slowly overwhelms their bonds. Gravity doesn't prevent loss, it gives loss a structure. Scientists study this slow unraveling through simulations and long-term models. They calculate stellar lifetimes, galactic mergers, and cosmic futures stretching far beyond any observer. The numbers grow enormous. The timescales dissolve intuition. Gravity remains the constant variable, guiding every projection toward quieter states. In these calculations, there's no drama at the end of time, just thinning, cooling, dispersal. The universe doesn't collapse in flames. It relaxes. Gravity gathers what it can, then releases its grip as expansion takes over. Even gravity, it seems, has limits in the very long run. This knowledge doesn't press down on you the way it might during the day. At night, it can feel oddly comforting. Gravity isn't rushing toward an ending. Neither are you. The vastness of cosmic time makes individual moments gentler, not smaller. Your presence here is brief, but it is not fragile. The same force that will one day guide stars into stillness is currently holding your body with perfect consistency. There's no contradiction in that. Gravity doesn't distinguish between the monumental and the intimate. It applies the same rules everywhere, scaling naturally from galaxies to breaths. There's a quiet intimacy in sharing a force with the entire universe. Gravity doesn't belong to distant objects alone. It belongs to you just as much. Every thought, every memory, every moment of rest unfolds within its structure. You are not separate from the cosmos. You are participating in it. This participation doesn't require effort or understanding. You don't need to grasp equations or futures. You're already included. Gravity includes everything by default. Nothing opts out. Nothing is forgotten. Even when structures dissolve, gravity has already done its work by allowing them to exist at all. Astronomers sometimes speak of bound systems, objects held together long enough to matter. By that definition, your body, your room, this moment are all bound systems, temporarily, gently, meaningfully held. Gravity is what allows for now to exist. There's no pressure in that realization, only permission to rest inside it. The universe isn't watching you closely. It's simply supporting you in the same way it supports everything else, without judgment, without expectation. If this thought drifts into sadness, it doesn't need to stay there. Melancholy and comfort often share the same space at night. Gravity doesn't choose one over the other. It holds both evenly. As the universe moves slowly toward quieter states, you are allowed to do the same. Nothing needs to be accomplished. Nothing needs to be resolved. Gravity has already done enough by keeping you here, steady, breathing, listening. For now, that's all that matters. There's a moment when thinking about gravity quietly reframes how small you feel. Not in a diminishing way, but in a clarifying one. Against galaxies and cosmic timescales, a single human life seems brief, almost weightless. And yet, gravity doesn't treat you as insignificant. It acts on you with the same seriousness it applies to stars, planets, and drifting clouds of gas. Every mass matters to gravity, no matter how modest. Your body curves space-time just a little, far too subtly to notice, but not zero. In the language of the universe, you are not invisible. Gravity registers your presence without judgment or hierarchy. The cosmos does not rank importance, it responds. This idea unsettles some people during the day, but at night it can feel grounding. You don't need to be enormous to belong. You don't need permanence to matter. Gravity doesn't ask how long you'll last. It simply includes you in the structure of reality while you're here. Astronomers often talk about negligible mass, a phrase used when an object is too small to affect calculations meaningfully. But negligible is not the same as non-existent. It's a mathematical convenience, not a statement of worth. Gravity still knows you're here, even if equations don't bother to mention you. There's a quiet relief in that distinction. You don't have to bend the universe to be part of it. You don't have to leave a permanent mark. Existing within gravity's field is already participation enough. The universe isn't waiting for justification. This perspective changes how absence feels too. When something ends, an orbit disrupted, a star burned out, a moment passed, gravity doesn't panic. It adjusts, it redistributes, it continues. Loss is not a failure of gravity. It's part of the process it enables. Physicists see this constantly in simulations. Structures form, merge, dissolve, and reform. Nothing stays fixed forever, but nothing is ever completely detached from the whole. Gravity ensures continuity even as forms change. Connection outlasts shape. You might notice how this mirrors memory. Experiences fade, details blur, but the influence remains. Gravity works similarly. A star long gone still shapes motion around where it once was. Its mass, redistributed, continues affecting the future. Endings don't erase impact. This doesn't mean everything lasts. It means nothing is wasted. Gravity doesn't hoard significance. It lets things move on while still contributing to what comes next. The universe carries its past gently, without clinging. For someone lying awake at night, this can feel like permission to let go. You don't need to hold every moment tightly. Gravity will take care of continuity. You are allowed to rest inside a larger process that doesn't require your constant attention. Even your thoughts follow this pattern. They arise, linger, drift, and settle elsewhere. Gravity keeps your body steady while your mind moves freely. One anchors, the other wanders. Both are allowed. It's easy to mistake smallness for isolation. gravity offers a different picture. Everything small is still connected, still accounted for, still influencing and influenced. Scale doesn't determine belonging. Participation does. In that sense, gravity is quietly compassionate. It doesn't privilege the loud or the lasting. It treats existence itself as enough. Being here, even briefly, is sufficient to be part of the structure. As you listen, you don't need to resolve how you feel about your place in the universe. You don't need a conclusion. Gravity doesn't demand one. It simply keeps you where you are, included, steady, supported. And maybe that's enough for tonight, to know that even in vastness, nothing that exists is truly separate, and nothing that rests is forgotten. As the night deepens, gravity begins to feel less like a problem and more like a companion, not something to argue with or analyze endlessly, but something that stays. It doesn't explain itself, and it doesn't need to. Gravity has already done what it came to do by keeping everything gently where it belongs, including you, exactly as you are in this moment. There's a quiet honesty in a force that never pretends to be complete. Gravity works without promising understanding. It shapes stars without narrating their lives. It bends time without explaining why time exists at all. In that way, gravity mirrors many things in human experience: reliable, present, essential, and ultimately mysterious. Scientists will continue to refine equations, build detectors, launch telescopes, and argue over interpretations. New theories will rise and fall. Some will illuminate small corners of the problem. Others will quietly fade away. Gravity will remain unmoved by these shifts, continuing to curve space and guide motion with patient consistency. What's remarkable is that this lack of final answers doesn't weaken the universe. It strengthens it. Mystery doesn't make reality fragile. It makes it spacious. There is room to exist without full comprehension, room to rest without resolution. Gravity demonstrates this every moment by functioning perfectly without ever being fully known. You can feel that spaciousness now, even if only faintly. The universe isn't asking you to understand it tonight. It's allowing you to be held by it. Gravity doesn't pull your thoughts toward conclusions. It lets them slow down, settle, or drift away entirely. There's a subtle kindness in that. Not everything meaningful needs to be grasped tightly. Some things are meant to support quietly in the background, unnoticed until you pause long enough to sense them. Gravity has always been doing that for you. From the beginning of the universe to this exact second, gravity has never taken a break. It has shaped chaos into structure, allowed matter to gather, enabled stars to shine, and made places stable enough for life to pause and reflect. You are one of those pauses. This doesn't mean you are small in a way that erases you. It means you are small in a way that fits. The universe makes room for moments like this, moments where nothing needs to happen, nothing needs to be proven, and nothing needs to be fixed. Gravity doesn't rush. It doesn't hurry you towards sleep or demand that you stay awake. It supports whatever state you drift into next. Whether you continue listening or slowly let go of words, gravity will remain steady beneath you. There's something reassuring in knowing that even when consciousness fades, the universe doesn't lose track of you. Gravity doesn't depend on attention. It doesn't require awareness. It will continue doing its work whether you're thinking about it or not. This is where the story gently loosens its grip. Not because it has reached an answer, but because answers were never the goal. The goal was to create a place calm enough to hold big questions without letting them overwhelm you. You don't need to remember everything you've heard. You don't need to carry the weight of unresolved physics into the rest of your night. Gravity already carries enough weight for both of us. As this part of the journey comes to rest, you're still exactly where you need to be, supported, included, and free to drift. The universe doesn't need your vigilance. It's comfortable handling itself for a while, and so without closing the mystery or tying it neatly, gravity does what it's always done best. It stays, it holds. And it allows the night to continue unfolding at its own unhurried pace. Even after everything gravity has shown us, there's still a quieter layer it influences, one we rarely notice because it feels like common sense. Reality itself feels stable, solid, predictable. Objects stay where they are, causes lead to effects, flaws remain beneath feet. Gravity plays a large role in maintaining that illusion of certainty, smoothing the universe into something that feels trustworthy. Without gravity, the concept of place would become fragile. There would be no natural resting points, no preferred directions, no easy distinction between drifting and arriving. Gravity gives the universe orientation. It decides where things gather and where emptiness spreads. In doing so, it turns abstract space into lived space, space that can be inhabited rather than merely measured. You experience this constantly without thinking about it. Your sense of balance, your awareness of vertical and horizontal, even your expectation that objects will remain where you left them, all of this depends on gravity's consistency. It's not just holding matter together, it's holding your assumptions together too. Physicists notice this when gravity is removed from equations as a thought experiment. Systems lose stability, solutions become degenerate, motion becomes ambiguous. Gravity acts like a quiet editor, trimming away chaos, narrowing possibilities into something coherent. Reality doesn't feel random because gravity refuses to let it be. This stabilizing role extends to cosmic history as well. In the early universe, tiny differences in density were amplified by gravity. Slightly denser regions pulled in more matter, growing into galaxies and clusters. Without gravity's patience, those small variations would have remained noise. Structure would never have emerged. Scientists reconstruct this process through simulations, starting with near-uniform conditions and letting gravity work slowly over billions of simulated years. The results aren't explosive. They're gradual. Filaments form, voids open, patterns emerge organically, like frost spreading across glass. Gravity doesn't impose structure abruptly, it coaxes it into existence. This gradual shaping is why the universe feels legible. There are patterns to recognize, scales to navigate, histories to trace. Gravity didn't just allow complexity, it paced it. Too fast, and nothing would last. Too slow, and nothing would form. The balance feels almost intentional, though physics doesn't require intention to achieve elegance. There's something deeply comforting in that balance. Gravity didn't need foresight to create habitable moments. It only needed consistency. From that, everything else followed. Stars burned long enough. Planets cooled slowly. Chemistry had time to experiment. Life found windows where conditions lingered just long enough to matter. You are part of one of those windows. Gravity helped make a place where nights exist, where rest is possible, where thought can slow down without dissolving into chaos. The same force governing clusters of galaxies quietly ensures that your body doesn't float away from this moment. What's striking is how little gravity announces itself while doing all this work. There's no sensation of force, no warning hum. Stability arrives silently. Only when gravity weakens or intensifies dramatically does its presence become obvious. In everyday life, gravity prefers to stay unnoticed. Researchers studying extreme environments, near neutron stars inside simulations of collapsing matter, see what happens when gravity pushes too hard. Order gives way to compression. Distinctions blur. Reality simplifies under pressure. In contrast, your environment represents gravity at its most generous, strong enough to hold, gentle enough to allow. This generosity doesn't come from kindness, but from balance. Gravity doesn't care what it supports. It treats everything equally. But that impartiality creates conditions where comfort can exist, not by design, but by consequence. At night, this can feel like quiet reassurance. Reality isn't fragile. It doesn't depend on your attention to remain coherent. Gravity will keep doing its work, whether you worry about it or not. The floor will still be there. The planet will still hold together. The universe won't unravel while you rest. As you listen, gravity continues shaping the unseen framework of everything around you. It doesn't demand gratitude or acknowledgement. It simply maintains the conditions that make listening possible in the first place. And if your thoughts drift here, toward the stability beneath everything, you don't need to follow them far. Gravity has already done enough by making this moment steady. You can let the rest remain in the background, quietly held. There is something gravity does exceptionally well that rarely gets mentioned. It absorbs drama. Where other forces announce themselves through sparks, flashes, and sudden change, gravity prefers restraint. It works through accumulation, through patience, through waiting. Even its most violent events unfold over timescales so vast that they feel almost quiet from a distance. A star doesn't collapse in an instant. It ages. It exhausts its fuel slowly, layer by layer, negotiating balance until it can't anymore. Gravity waits for that moment without urgency. When collapse finally comes, it is not an interruption of nature, but the completion of a long process. Gravity has been guiding from the beginning. From far away, even supernovae are softened by distance and time. Light spreads, shockwaves fade. Gravity remains after the spectacle, calmly reshaping what's left. Neutron stars form, black holes settle, orbits reconfigure. Gravity doesn't celebrate endings or mourn beginnings. It simply continues organizing what remains. This tendency toward quiet persistence is why gravity feels different from chaos. It doesn't amplify noise, it damps it. Motion eventually settles into orbits. Energy radiates away. Systems cool. Gravity encourages stillness without enforcing stagnation. It allows movement, but prefers balance. You can feel this preference reflected in your own body. When you stop moving, gravity doesn't force you to collapse. It allows rest. Muscles release tension. Breathing slows. Weight becomes evenly distributed. Gravity doesn't rush you towards sleep. It makes sleep possible. Physicists see this calming influence in equations describing stable systems. Bound orbits, equilibrium states, conserved quantities, all expressions of gravity's tendency to settle systems into long-lasting configurations. Instability exists, but gravity resists it whenever possible. This resistance shapes cosmic history in subtle ways. After the chaos of the early universe, gravity helped smooth irregularities, allowing matter to collect without tearing itself apart. Structures formed gradually, avoiding violent extremes most of the time. The universe learned how to persist. Even gravitational waves, ripples in space-time itself, carry this signature. They are not explosions, but echoes. Gentle stretches and compressions passing through space, barely noticeable by the time they reach Earth. Gravity communicates through whispers, not shouts. Human instruments built to detect these whispers had to become incredibly sensitive. Lasers measured changes smaller than a proton's width. Mirrors were isolated from vibrations. Scientists waited years for signals buried deep in noise. Gravity didn't make detection easy. It asked for patience. This patience is mirrored in the way gravity shapes time's experience. It doesn't hurry moments along. It allows them to linger. Near massive objects, time slows. Near calm masses, time feels steady. Gravity doesn't impose a universal tempo. It lets each region find its own rhythm. There's something deeply aligned between this behavior and the quiet of night. Gravity doesn't demand action. It doesn't require attention. It allows you to exist without responding. In a world that often rewards reaction, gravity models a different approach, presence without urgency. You don't have to engage gravity actively to benefit from it. You can ignore it entirely, and it will still hold you. This unconditional reliability is rare. Most systems require maintenance, feedback, correction. Gravity simply stays. In theoretical work, this raises uncomfortable questions. If gravity prefers quiet outcomes, why does it permit extremes at all? Why black holes? Why singularities? The answers remain incomplete. But even these extremes, once formed, become stable again. Gravity absorbs disturbance and returns to stillness. Perhaps this is why gravity feels trustworthy despite its mysteries. It doesn't behave erratically. It doesn't change character suddenly. Even where it breaks our equations, its behavior remains consistent. The failure is ours, not its. As you listen, gravity continues this quiet labor without interruption. It doesn't mind if you're awake or drifting. It doesn't care whether you're thinking or forgetting. It simply keeps the conditions steady enough for either. And in that steadiness, there is no demand placed on you. Gravity doesn't ask you to participate more fully or understand more deeply. It's enough that you're here, supported, while everything else settles into silence around you. There comes a point where gravity stops fitting comfortably into words. Equations stretch, metaphors thin out. Even the most careful explanations begin to feel like approximations circling something just out of reach. Gravity doesn't resist language out of hostility, but out of scale. It operates across distances, times, and conditions that human intuition was never designed to navigate. Physicists are keenly aware of this gap. They speak in symbols because ordinary language collapses under the weight of precision. Even then, the symbols are provisional. They work within limits, fail beyond them, and are replaced by new ones that fail more gracefully. Gravity sits patiently at the edge of every description, unconcerned with how well it's been translated. You can feel this limit without touching a single equation. Try to imagine curved space not as a fabric, not as a grid, not as anything familiar. The images dissolve quickly. Gravity doesn't occupy space the way objects do. It defines space, and definitions are harder to picture than things. This difficulty shows up clearly when scientists try to explain gravity to each other across disciplines. A particle physicist speaks in quanta and interactions. A relativist speaks in geometry and curvature. They are describing the same universe, but the languages don't align. Gravity sits between them, untranslated. Attempts to bridge this divide often rely on analogy. Space-time as rubber sheets, gravity as attraction, time as a river. These metaphors help, but they also mislead. They suggest pictures that break down under scrutiny. Gravity tolerates these simplifications only because they're stepping stones, not destinations. In this way, gravity teaches humility. It reminds us that understanding doesn't always mean visualization. Some truths are relational rather than pictorial. Gravity is not something you see, it's something you infer from how everything else behaves. This is why gravity feels so present and yet so elusive. You live inside it continuously, but never encounter it directly. There's no sensory organ for gravity itself, only for its consequences. Weight, balance, orientation. These are translations, not the original signal. At night, this absence of direct access can feel oddly comforting. You're not failing to grasp gravity. No one ever has. The universe didn't design it to be grasped in that way. Gravity doesn't require comprehension to function perfectly. Scientists sometimes joke that gravity is polite but uncooperative. It obeys every test, but refuses to explain itself. It produces consistent outcomes while hiding its mechanism. This combination is rare. Most mysteries either misbehave or resolve. Gravity does neither. In research papers, this shows up as careful language. Words like suggests, indicates, and may imply appear frequently. Certainty is rationed. Claims are restrained. Gravity encourages caution, rewarding those who leave room for the unknown. You can imagine researchers rewriting sentences late at night, softening conclusions, acknowledging uncertainty, not because they lack confidence, but because gravity has taught them restraint. Overstatement collapses quickly under its weight. This restraint carries over into how gravity shapes philosophical thought. It challenges the idea that reality must be fully expressible to be real. Some aspects of existence may resist final explanation while remaining entirely consistent. Gravity embodies that possibility. For someone listening quietly, this can be a relief. You don't need to articulate everything you feel or understand everything you experience. Gravity validates the idea that functioning doesn't require fluency. Your body understands gravity without language. It relaxes into support. It distributes weight intuitively. It responds without narrative. This silent understanding is enough. As the universe continues moving under gravity's guidance, words remain optional. Models will change, descriptions will improve. But gravity will remain what it has always been, present, consistent, and unconcerned with how neatly it fits into our sentences. For now, you can let the words fade slightly, knowing that even when language thins out, the structure beneath everything remains steady, quietly doing its work while you rest. There is a subtle way gravity reshapes how we think about cause and effect. In everyday life, causes feel immediate. You push, something moves. You drop, something falls. Gravity complicates this intuition by acting across distance without ever touching. It doesn't collide. It doesn't transmit through contact. It simply exists as a relationship, and that makes it harder to locate in time. Einstein's view of gravity dissolves the idea of instantaneous action. Changes in mass and motion ripple outward at the speed of light, carried by space-time itself. Gravity doesn't respond everywhere at once. It responds with delay, like a deep ocean adjusting slowly after a shift. The universe takes time to notice itself changing. This delay has been measured. When massive objects move, space-time ripples travel outward as gravitational waves. By the time these waves reach Earth, they are faint echoes of ancient events, collisions that happened millions or billions of years ago. Gravity tells stories late, but faithfully. Scientists learned this by building detectors sensitive enough to notice space-time stretching by less than the width of an atom. Mirrors suspended in vacuum chambers, lasers bouncing back and forth in silence. Decades of effort waiting for a signal subtle enough to be almost dismissible. Gravity didn't rush the reveal. What's striking is how calm these waves are by the time they arrive. They don't shake the ground or announce catastrophe. They pass through Earth gently, stretching and compressing space so slightly that nothing notices except instruments designed to listen patiently. Gravity communicates softly, even when describing violent events. This softness changes how cause and effect feel at cosmic scales. Events don't resolve quickly. Consequences unfold slowly, layered across time. The universe carries memory in its geometry, letting influences propagate gradually rather than explosively. You can sense a version of this in your own life. Not everything registers immediately. Some experiences take time to settle. Understanding arrives late, reshaped by distance from the event itself. Gravity's delayed response mirrors this rhythm. Physicists incorporate these delays carefully into their models. Ignoring them leads to predictions that drift out of sync with observation. The universe doesn't accept shortcuts. Gravity insists on patience, even in calculation. This insistence challenges older intuitions about determinism. If effects take time to propagate, then the universe is always slightly behind itself. What you experience now is shaped by events long past, some beyond reach, others quietly nearby. Gravity binds moments together across distance and time. Despite this complexity, nothing feels unstable. The delays don't create chaos, they create coherence. Systems adjust smoothly, absorbing change rather than amplifying it. Gravity acts as a buffer, not a trigger. This buffering role is one reason gravity feels dependable. It doesn't react impulsively. It integrates information over time, allowing systems to adapt. In a universe governed by instant response, nothing would last long enough to matter. The human effort to measure these delays reflects gravity's character. Long experiments, extended observations, repeated calibration. Gravity rewards those who wait, rather than those who rush conclusions. You don't feel these delays in your body tonight. Gravity here is settled, its signals long resolved. The Earth's mass hasn't changed significantly in billions of years. The space-time around you is calm, unperturbed by distant drama. This calmness is not accidental. It's the result of gravity having had enough time to smooth things out. The present moment exists because countless adjustments have already happened. And yet, this same force that creates calm through delay also hints at something deeper. Something about how the universe remembers itself, how past and present remain quietly connected through gravity's slow messaging. That thought doesn't need resolution yet. It can remain open, gently suspended, because in the next part, we'll follow this thread further into how gravity ties memory, persistence, and continuity together in ways we rarely notice, but always live within. Gravity doesn't only connect objects across space, it connects moments across time. Long after events have passed, gravity continues to carry their influence forward, quietly preserving relationships that would otherwise dissolve. In this sense, gravity acts less like a force and more like a memory woven into the structure of the universe itself. Every orbit you've heard about is a record of the past. The path a planet follows today is shaped by how mass was distributed millions of years ago. The galaxy you see overhead is not a snapshot of the present, but a layered archive of earlier states, each one held in place by gravity's consistency. Nothing moves freely of its history. Physicists become acutely aware of this when modeling long-term systems. Small differences in initial conditions echo forward, amplified gently by gravity's patience. A star's motion today contains information about interactions long forgotten. Gravity doesn't erase history, it integrates it. This integration is why the universe feels continuous rather than fragmented. Without gravity, reality would feel episodic, moments disconnected from one another, events failing to accumulate meaning. Gravity provides narrative. It allows sequences to exist rather than isolated flashes. You experience this narrativity indirectly. Your body remembers balance. Your inner ear recalls orientation. Your muscles anticipate weight before it arrives. Gravity has trained these expectations over a lifetime, embedding continuity into sensation itself. Even rest is learned. In astronomy, this persistence becomes visible in structures like tidal streams, faint trails of stars pulled from galaxies during ancient encounters. Long after the interaction ends, gravity preserves the evidence, stretching it gently across space. The universe remembers, even when no one is watching. Human observers reconstruct these memories slowly, Telescopes gather light, data accumulates, simulations replay billions of years in compressed form. Scientists watch gravity replay its own past, step by step, verifying that consistency extends backward as reliably as it extends forward. This backward reach of gravity challenges the idea that the present is all that exists. The now is shaped continuously by the then gravity refuses to isolate moments. It insists that time be relational, not absolute. At night, this can soften how memory feels. Your past doesn't need to press urgently into the present. Gravity already carries enough of it forward. You don't need to hold everything consciously. Continuity is maintained without effort. Loss, in this framework, becomes less absolute. When something ends, its influence doesn't vanish. Gravity redistributes it, folds it into new arrangements. Matter moves on, but relationships persist in altered form. Endings are transformations, not deletions. This is why cosmic evolution feels calm even when dramatic events occur. Collisions reshape systems, but gravity absorbs the disruption and settles the aftermath. The universe doesn't forget how to be itself. Your own experience mirrors this on a smaller scale. Moments pass, thoughts fade, but you remain oriented. Gravity maintains a baseline of presence beneath shifting mental states. Even when attention wanders, support does not. There's no demand here to extract meaning actively. Gravity doesn't interpret history, it carries it. The burden of narrative isn't placed on you. Scientists sometimes speak of conservation laws as the deepest rules of physics. Gravity honors them quietly, ensuring that nothing is truly lost, only rearranged. Reality keeps accounts even when memory falters. This quiet accounting gives the universe a sense of fairness without intention. No moment is privileged. No experience is erased. Everything contributes to the ongoing shape of what follows. As you lie here, gravity is doing this same work for you. It's holding the present steady while carrying the past gently forward, allowing you to rest inside continuity without needing to reconstruct it. And that continuity doesn't end when awareness fades. Gravity doesn't depend on attention. It will continue remembering for you long after sleep arrives. There is a subtle way gravity protects reality from fragmentation. In a universe without it, interactions would be brief, accidental, and easily undone. Gravity slows things down. It allows encounters to last long enough to matter. It gives duration to relationships that would otherwise scatter. Consider how quickly particles move at cosmic temperatures. Without gravity binding them, matter would disperse endlessly, never settling into structures complex enough to persist. Gravity doesn't create complexity directly, but it makes patience possible, and patience is what complexity needs. This patience shows up in the long lives of stars, the slow formation of planets, the gradual cooling of worlds. Gravity allows time for chemistry to experiment, for patterns to stabilize, for fragile arrangements to survive repeated disturbances. It doesn't rush outcomes. Physicists recognize this when they calculate stellar lifetimes. Without gravity's exact strength, stars would burn out too fast or never ignite at all. The balance is narrow, precise, and strangely forgiving. Gravity gives systems room to breathe. That breathing room extends inward to biological and psychological scales. Gravity stabilizes environments enough for rhythms to form, day and night, sleep and waking, rest and effort. It doesn't dictate these rhythms, but it supports them. At night, you're inhabiting one of gravity's gentlest products, a stable interval. Nothing dramatic needs to happen here. The world is not asking for reaction. Gravity has already secured the basics. In research, scientists often look for instability as a sign of error. Systems that explode numerically or diverge wildly usually signal missing constraints. Gravity often provides those constraints, preventing runaway behavior in equations and in reality alike. This constraint is not restrictive, it's enabling. By narrowing possibilities, gravity makes outcomes meaningful. Without it, everything would be equally possible and therefore insignificant. The universe under gravity is selective. Not everything happens. Some arrangements persist, others dissolve. This selectivity creates history. It allows cause and effect to accumulate rather than reset. You can feel this selectivity in how your body settles into a comfortable position. Not every posture works. Gravity gently rejects some and rewards others with stability. Comfort emerges from constraint, not freedom. In cosmology, this same principle governs large-scale structure. Filaments form where gravity allows them. Voids open where it does not. The universe acquires texture, not uniformity. This texture is what makes the cosmos legible. Patterns emerge. Differences matter. Gravity doesn't flatten reality. It sculpts it slowly, patiently, without urgency. When physicists speak about fine-tuning, gravity often sits at the center of the discussion. Its strength appears delicately balanced, too strong, and the universe collapses early, too weak, and nothing holds together long enough to matter. Gravity occupies a narrow window where existence is allowed to linger. This lingering is what you're experiencing now. The night stretches. Time softens. Nothing demands immediate resolution. Gravity has already carved out this pause. There's no obligation to reflect deeply on that fact. It's enough to notice that stability is not accidental. It's earned, moment by moment, by a force that never stops doing its quiet work. As consciousness loosens, gravity remains vigilant. It doesn't sleep. It doesn't drift. It maintains the scaffolding of reality while awareness comes and goes. And if sleep arrives soon, gravity will continue holding everything exactly as it is supposed to be, keeping the world intact while you step away from it for a while. Nothing will be lost in that absence. Gravity will still be here, patient as ever, maintaining continuity until you return. Gravity has a way of revealing how little effort the universe actually uses to remain itself. Nothing about gravity feels frantic. It doesn't correct constantly or intervene aggressively. Instead, it establishes conditions and then steps back, letting systems unfold within those boundaries. The universe feels active, but gravity itself is remarkably restrained. This restraint becomes clear when you think about how rarely gravity changes its rules. Other forces behave differently depending on energy, distance, or context. Gravity remains consistent across scales, from falling dust to orbiting galaxies. Its predictability is not a limitation. It's a foundation. Physicists depend on this reliability when everything else becomes uncertain. Even when equations fail at extremes, gravity still behaves coherently. Black holes follow rules. Orbits remain stable. Large-scale structure holds. The breakdown occurs in description, not behavior. This difference matters. It suggests that gravity may be deeper than our theories, not shallower. The universe isn't confused about gravity. Gravity continues doing what it does, regardless of how incomplete our understanding remains. You can feel the benefit of this depth right now. Your body isn't negotiating with gravity. It isn't correcting itself continuously. Stability is automatic. The floor holds, the bed supports. Orientation doesn't need conscious upkeep. Gravity has already done that work. In this way, gravity acts like an underlying agreement the universe made with itself long before observers arrived. Once established, that agreement didn't need constant revision. Everything else builds on top of it. Scientists sometimes wonder whether gravity is not just one force among others, but the background condition that allows forces to make sense at all. Without gravity anchoring space-time, interactions would lose context. Distance, duration, and sequence would become ambiguous. This anchoring role shows up clearly when gravity weakens. In simulations where gravity is reduced, structures dissolve. Meaningful patterns fail to persist. The universe becomes restless, unable to settle into anything long enough to matter. Gravity's contribution then is not excitement, but permission. Permission for things to stay. Permission for systems to remember themselves. Permission for complexity to accumulate rather than reset endlessly. This permission extends to thought as well. You're able to follow ideas slowly because gravity stabilizes your physical presence. Without that stability, attention would fragment. Reflection would be impossible. At night, this stabilizing effect becomes more noticeable because everything else quiets down. The absence of noise reveals what has been supporting you all along. Gravity doesn't fill the silence. It makes silence possible. There's no demand placed on you by this realization. Gravity isn't asking to be acknowledged. It doesn't need appreciation. Its role is already fulfilled by continuing to exist exactly as it does. Researchers often search for deeper explanations because they sense that gravity is carrying more meaning than equations alone can express. But even without those explanations, gravity remains sufficient. The universe functions without commentary. This sufficiency can feel comforting. Not everything needs a story attached to it. Some things simply need to work. Gravity does. You don't have to align your thoughts with cosmic truth tonight. You don't have to extract lessons or insights. Gravity doesn't operate through interpretation. It operates through consistency. As you remain here, supported without effort, you are benefiting from one of the universe's most reliable habits. Gravity hasn't failed once in doing this simple job, and when sleep eventually arrives, gravity won't notice the transition. It will continue holding everything steady, just as it always has, without interruption. There is something quietly radical about a universe that doesn't require constant supervision. Gravity allows reality to persist without monitoring. Systems don't need awareness to remain stable. The cosmos doesn't collapse when no one is watching. Gravity keeps things together even in total darkness. This independence from observation contrasts sharply with quantum mechanics, where measurement plays a strange and central role. Particles behave differently when observed. Probabilities collapse. Outcomes crystallize. Gravity, by contrast, seems indifferent to attention. It doesn't wait to be noticed. Physicists find this contrast deeply unsettling. How can one part of reality depend on observation while another remains utterly autonomous? Gravity doesn't acknowledge the observer at all. It continues shaping space-time whether anyone is there to describe it or not. This makes gravity feel ancient in a way few other concepts do. It doesn't care about perspective. It doesn't adapt to interpretation. It simply maintains relationships between masses and distances, quietly enforcing coherence. From a human point of view, this can feel reassuring. You are not responsible for holding the world together. The universe doesn't depend on your vigilance. Gravity has already assumed that role. At night, this can soften anxiety. Nothing catastrophic will happen because you stop paying attention. Gravity doesn't need oversight. It has been managing far more complex systems for far longer than human awareness has existed. Astronomers witness this indifference firsthand when studying regions of space that have never been observed before. Gravity shaped them anyway. Stars formed, orbits stabilized, structures emerged without witnesses. Even now, gravity is sculpting parts of the universe no telescope will ever reach. Entire histories are unfolding unseen. Reality does not wait for documentation. This realization subtly shifts how importance feels. Significance doesn't require recognition. Events matter because they occur, not because they are recorded. Gravity validates existence without asking for acknowledgement. Your own presence follows this same logic. You don't need to be witnessed to be real. Gravity responds to you regardless of attention, measurement, or interpretation. You are included by default. This inclusion doesn't elevate or diminish you. It simply places you inside the same structure as everything else. Gravity doesn't sort by meaning. It treats all mass with the same seriousness. For scientists, this impartiality is both comforting and frustrating. Gravity never plays favorites, but it also never explains itself. It enforces order without revealing intention. Yet that order is enough. The universe doesn't require narrative clarity to function. Gravity demonstrates that coherence can exist without explanation. As words slow down now and thoughts become less distinct, gravity remains clear. It doesn't blur. It doesn't fade. It continues holding everything in alignment while consciousness loosens. You don't need to stay awake to maintain connection. Gravity doesn't disconnect when awareness drifts. It remains fully engaged with reality even when you are not. This is the quiet gift gravity offers every night. Permission to let go without consequence. The world will remain intact. The structure will hold. And as this long exploration settles into silence, gravity will still be here, unseen, uninterested in recognition, doing exactly what it has always done, while you rest inside the stability it provides. Somewhere back at the beginning of this night, a question was placed gently in the air, not as a challenge to solve, but as something to sit with. Gravity, so familiar, so dependable, revealing itself as the one force that quietly breaks our physics when we ask it to explain everything. Since then, we've wandered through curved space and stretched time, invisible mass, unfinished equations, human patience, and the long memory of the universe itself. The question never demanded an answer. It only asked for attention. Now, as this journey slows, you might notice how little urgency remains. The universe did not collapse because gravity stayed mysterious. It continued functioning perfectly while our understanding lagged behind. Stars still orbit, time still flows. Your body is still supported exactly where it needs to be. Whatever gravity truly is, it has never waited for explanation before doing its work. Throughout this night, gravity has appeared again and again, not as a villain or a flaw, but as a quiet boundary, a place where language thins out, where equations stop being enough. Where certainty gives way to consistency. It doesn't shout its limits. It simply holds them calmly, letting us discover where our tools fall short without punishing us for asking. We've seen how humans approach this force, with telescopes aimed carefully into darkness, with detectors listening for whispers in space-time, with equations rewritten late into the night. We've watched scientists fail, adjust, argue, and try again. And through all of it, gravity remained steady, neither impressed nor offended, continuing to shape reality while being partially understood. There's something deeply reassuring in that arrangement. The universe does not require perfect comprehension to remain stable. Reality does not depend on us getting everything right. Gravity teaches this lesson quietly, by example. It works without explanation. It supports without commentary. It allows mystery without chaos. As you return, gently, to the awareness of your room, your bed, your breathing, you're coming back to gravity in its most intimate form, not as curved space-time or cosmic structure, but as quiet weight, as contact, as rest. The same force shaping galaxies is shaping this stillness right now, without asking anything from you. If parts of this story blurred together or faded entirely, that's not a failure. That's exactly how nights like this are meant to work. Understanding was never the requirement. Presence was, and even presence was optional. Gravity held everything together, whether you followed every idea or let them drift past like distant lights. You might be listening from a place where the night is deep, or where morning is just beginning. Somewhere else, someone is hearing these same words at a completely different hour, under a different sky, held by the same force. It's strangely comforting to know that gravity connects all of those moments without effort. If you'd like, you can leave a comment sharing where you're listening from and what time it is where you are. Not as a metric, but as a quiet marker of shared stillness across the planet. And if nights like this, slow science, big questions, no pressure, feel like something you'd want to return to, you're always welcome to subscribe and come back again. But even if you don't, even if this is the last word you hear before sleep takes over, nothing is lost. Gravity doesn't require continuity of attention. It will keep holding everything in place while you rest, dream, or drift away entirely. There's no final answer waiting at the end of this story, only a softer relationship with the question. Gravity remains incomplete in our theories, but complete in its presence. That's enough for tonight. So wherever you are now, eyes open, eyes closed, somewhere in between, you can let the universe handle itself for a while. Gravity already has,